Hello.
Hello, Harry, Damien, Bettina, and Ivan. So should we give the rest of the crew 1 minute and then we will start?
Yeah.
All right, let's go.
I'm afraid there's no sound coming off the video for us.
Sorry?
There's no sound coming off the video for us.
I will go back here. Sorry about that. That you want to study a session on session recipe building. This is the way you build automated workflows in Bidiomiter Lab software. And we're excited to show you how this is done, because once you have built session recipes, then you can do the routine tasks of analyzing images in a very simple way, just by basically one push of a button. Today, spectral imaging can be used not only in research and development. Spectral imaging is a field that can provide very fast and versatile non-contact measurements in the lab of samples that you want to study on a routine basis, or it can be used in production, headline, online, inline, to give a very versatile set of product or process parameter. So it's used in many different situations where you want to standardize the workflow as part of a protocol. So let's see how this works. Sessions are built through the session manager, which is available in the session main menu. And you can see that you can specify how to input images, how to process them, and how to output or what to output. And it's simply a systematic way to define all the steps taken during analysis of the images. In the session manager, you can choose to specify the light setup if you want to include image acquisition as part of the session. Then you have a segmentation, which defines where to measure in the image once it's taken. And then you have different session plugins, which define different types of quantification in the images. So the first default session plugin is the statistics plugin, and that measures pixel statistics within the foreground. So that could be mean spectrum, mean color, distribution of spectrum or color. It could also be histograms and so on. In the MSCI blob counter, you try to quantify what is known as blobs in the images. So that would be, for instance, pores in a bread slice, and blob is standing for binary labeled objects. And first you need to segment out all the pores, and then you can make a pore size distribution, or you can count the pores, or you can measure the total area of pores. And that is the MSI blob counter. In the MSI area fraction, we measure the sort of area distribution of different components in the foreground. So that means we can say how much pore is there and how much dark spots are there in milk powder, scorched particles, for instance. What is the fat relative area in a salami slice, and all similar types of area fraction measurements. So the last one is the MSI blob classifier, which is a more flexible way to do blob classification, blob quantification than the blob counter. In this case, you extract all the blobs of the image and you can measure a very versatile set of blob features defining size, shape, texture, contour, and other properties of the blobs, and make averages and standard deviation of all those features. At the last part of the session manager, you can specify runtime options and output preferences, so you can say which formats you want and how much output you want, and you can also define whether the input source should be defined at runtime or at design time for the recipe. So let's move into this. So the Bidiomiter session is a session runner, you can say. Once you have made a session recipe, it's called an SRCP file, and that can actually be taken to your desktop, and you can have different routine tasks on your desktop. Like we see here, we have 3 routine tasks, and then you can simply double click one of the tasks and it will immediately start up the session, and you will not have to start up with the exploratory Bidiomiter Lab software. You start directly running the session if you use this tool. So the concept of a session recipe is sort of the description of the complete workflow throughout the session. One session is one session of measurements with a given experimental plan where you want to sit and maybe measure 100 samples or 200 samples, and then every time you put in a new sample, you will click the button, and then it will automatically acquire the image if that's what you have asked it to do, and then it will correct it. It will do the segmentation that you have asked it to do the measurements, and output the result as you have specified. Then it's ready for the next sample, and you do everything all over again with one push of a button. So we will start now with the session building with a simple example of measuring color of powders presented in a petri dish. In this application, we want to measure the color of a powder presented in a petri dish. So you put a certain amount in each petri dish and vibrate the dish so to distribute the powders evenly on the dish. And then you can measure the powder within the dish, and typically you may have some unevenness of the powder distribution around the edge. So we would typically measure within a margin of 5 millimeters from the outer edge of the petri dish. So just to highlight how much a 5 millimeter is, we can choose the line tool and the profile here. So I will take the line tool and go 5 millimeters in. So you can see that this is around 5 millimeters, and that you see down here. And then we say, okay, we only measure what's inside that perimeter of 5 millimeter inside the petri dish. So in order to measure the powder color, then we can also on the same time measure the, let's say, the distribution of powder color. And this we do in order to see the effects of white tint, spots of white tint on the powder. In this case, we have 2 clear spots of white tint, but on the right powder you have a lot of spots of white tint. So we want to not measure the individual particles, but we want to make a session recipe that quantifies the color within the powder and also the distribution of powder color. So let's try to make that kind of recipe, and for doing that we need 2 things. We need to define a segmentation that takes the petri dish and goes 5 millimeter into the dish, and the other part is to make a session recipe that measures a certain set of color parameters within that segmented region. So let's try with the first step, which is the segmentation part. We choose the segmentation builder, and we just need the pre-segmentation because there we do have a petri dish segmentation. We choose manual instead of automated, and we choose the 5 millimeter margin, and we can apply that to either of the images. Let's try to apply it to the OK image here and apply it as a layer, a blue layer. So now you should be able to see the active measurement area that we are going to quantify the color in. We can also do it, of course, on the other image here, apply as a layer, and we see the same defined region on the other image. So that looks pretty nice that we can quantify the color within that region automatically, no matter how you have placed the petri dish on the blue plate. So let's save this segmentation. We call it petri dish with 5 millimeter margin, and I save it, and then we leave this one. We can go up here and clear the layer because we don't need that anymore. We clear also the layer on the other image and go back, and now we enter into the second step, which is the session manager, where you define complete workflows for the image analysis. We make a new session recipe called we want to measure CLAP color in petri dish with 5 millimeter margin. So that's our session recipe we want to make. We don't want really to do anything about the input here, which is the first part of a recipe, because we want to get them from disk, so we don't want to impose any restrictions on how the images are generated. On the processing side, we want to choose the general one, general statistics, which is also the default, and we go in here to edit the settings. And the first thing I need to do on the edit settings is to define where to measure the color, and for that I need my user-defined petri dish with 5 millimeter margin segmentation. That means we will measure within that. And what do we want to measure? The color space we want to measure in is the CLAP, so we want to measure LAB values. We can also choose the illuminant, which is typically chosen as D65, noon outdoor daylight, and we can also choose area unit for selecting areas we want to quantify. So in this case we set a minimum to 0 area and a maximum to 10,000 square millimeters, which will be enough to accept the whole image as a measurement area. So let's go down here, or first up, then we see that we can also append parameter from the histograms. but we will not do that. We will just make a simple statistics where we measure the statistics mentioned down here. We have ticked on true for mean and standard deviation, and false for the rest, which could be coefficient of variation, median, skewness, kurtosis. So we will only get the mean and the standard deviation of L, A, and B parameters, as well as for the spectral parameters that we get from the image. So let's go with those parameters, and on the output preferences, we don't really need to do anything unless we want extra output. We can take on here PNG so that we get some PNG files illustrating where we measure on each image. And we can of course also save the HIPS images that we get in, but since we are loading them from already saved images, we don't need to save them again. So let's see if we can run the session. We will save the recipe before running and save it under the name that I gave. And now we are running the session. This is how it looks. Once you click on the session, I will choose images coming from file load, and I can select the folder, which will be my download folder, my powder color folder here. And I have the two images that I'm showing here on that folder. And I will say OK. And now we are ready with running the session here. So this is the session runner, and you see that it has some area here for illustrating images, and here we have some parameters that we compute from the images. And all I have to do is click on play down here. Then it will load each image. Now it's loading, and then it will calculate these parameters after segmenting out the petri dish and taking the 5mm margin. Now it gives me some area, and this is the view file that shows the area which has actually been measured, and everything that is not measured is shown as black. And you can see that the background and the petri dish is not measured. And now you see that the second dish has also been measured, and we can look a little bit on the parameters. See here we have a similar total area of powder that we are measuring. We have the mean spectrum here, mean of band number 1, 2, up to 19. We also have the mean of L, A, and B, and you can see that for the image which is not okay, the one with a lot of white tint, you can see that the parameters are indeed brighter. So L is larger for the not okay than for the okay, and also there is a slightly less, you can say, saturation in the color because A and B is less. We can also show an effect on the standard deviation. If we go all the way to the right, then we see the standard deviation of L, A, and B, and we see that if you have the white tints, then you have an increased standard deviation. And not on the B, but I would definitely go for the lightness in this case as an indicator of white tint on the powder. So that was the first recipe. We now have made a run of that recipe, and I leave the runner here, and I go back. I can go to my folders, preference folders, and look at my user folder, and in that user folder I will see session results, and we can see that we have session results from the recipe called CLAB color in petri dish with 5mm margin. So that's the one we just ran. We can see that we have run it one time, that recipe, and this is like a running number. So for the first run we got these results. So we have two PNG images showing the measurement area, and we do have a Excel file which is now showing here with the results. So in this case, we see all the measurements for the 2 images, timestamp, image file where we do have them, and also the reflectance values, the mean LAB, the standard deviations of reflectance values, and the standard deviation of the LA and B here. So all of those are stored in Excel and can be used as records of measurements for the 2 samples. The next example is on measuring coating on rice, paddy rice, and shows the use of the statistics plugin again, but in a slightly different setting. Here we start with 2 images for constructing a rice coating recipe. On the left we see a control sample, so that is paddy rice completely uncoated. And on the right you see a petri dish with coated rice that we define as the reference coating. So now we want to do a recipe that finds out what is the homogeneity and the average loading of the coating on the rice seeds based on these 2 images. So let's start with defining some regions, because first of all we need to remove the petri dish and the background from both images, and then we need to define a transformation that shows you the abundance of coating on the individual pixel of every seed. So in order to do the first, then we go in and paint what we can call the background, and I choose the way I usually do by spotting different parts. So the background would be outside here and here. And also, if we go into the darker areas of the blue here, and we can maybe find other areas as well, a little bit of dust, and maybe I can also go to the other image and define how the background looks by choosing this region. And I also go a little bit out here on the outside of the petri dish. It's a glass petri dish, so we need a slightly larger margin than we do for a plastic petri dish in this recipe, but we come to that later on. So yellow is now my background, and we can go to define our product. So that could be either coated or uncoated seeds. So I will choose some seeds that are coated and partially coated here, areas that I see as representing the coated seeds or partially coated seeds. And then I will also go over here and say this is also seed when I think about separating seeds and background. I'm not considering the coating yet, but mainly different aspects of seeds in relation to the background. So this is the first part, and then I will come back to the painting when I want to do the coating transformation, but now we want to do a segmentation that segments out the seeds automatically. We choose the segmentation builder and we do the pre-segmentation. Again, I would probably not choose the automatic because it's usually set up for plastic petri dishes. So here we have a slightly larger edge of the dish, so I will just try to apply that as a red layer. And we see here that we do get a certain part of the mirror reflection of the outer seats here. So I want to move a little bit this way, so I may want to use 3.4 instead, and I apply that as a red layer again, and you see now I'm just about in between the outer seat here and the mirror image of the outer seat. So that seems to be quite a good trade-off. So let's see here, we want now to also remove the background, and in order to do that we need to have a transformation. And right now we do not have a foreground background transformation, so I will have to get back on that. I will go into Transformation Builder and I will choose my two images, and I want to separate blue layer from yellow layer. So in order to get the seats versus the background, I will now create an NCDA, and that gives me a signal to noise ratio of 80 standard deviations. So I have pretty good discrimination between foreground and background, and I can also apply it to my control image. You see it here. So in the control image, seats are red and background is blue. And if I apply it to my coded image, then we have the same thing. Seats will be red, yellow, and background will be blue. So I could further elaborate on it a little bit, but I will just use this for now, and I will save this as coded rice. No, I'll just say coded and uncoded rice versus background. And I will save my transformation here, go back to my segmentation builder, and in the segmentation builder I will now select that transformation. So we have coded uncoded rice versus background, and I will select that, and we will threshold at 0 as we typically do with NCDA, and choose the foreground as what is larger than 0. So that's the yellow red area over here. So that should leave us with an image which only give us the foreground. So I can go back to my control image, and I will now apply it as the red layer again. So now we only get the grain. And that means we can now save this and call it coded and uncoded rice versus background. A little bit the same as the transformation, but now it's the segmentation, as you see down here in the type of the file. Save it, and now we can use that for future analysis. So that was the segmentation. The next step would be to go, and I will now actually clear that layer. So now we have still painted the yellow and blue as background and foreground, but now we want to define the coded areas with red and the uncoded with yellow. So I could go ahead and say I will choose a smaller paintbrush. The reference coding is defined as what I set to red now. So this will be my definition of the reference coding. Those areas, or the mean of those areas. So I make sure that I don't include too much area from uncoded areas, exposed areas like here. So I only include the actual coding areas. I can then choose the uncoded, and that is done simply over here by painting a lot of uncoded paddy rice, including also the dark parts and so on. So everything I paint here is uncoded. I could also include parts of the sterile lemma here if I want, so I can choose a slightly finer brush. So, and now we want to make the coding transformation, and to do that I call the transformation builder again, and now I want to make an NCDA between red and green layer, and I have a small twist to it because I go into advanced setting, and instead of having a transformation that maps between -1 and 1, then I select 0 to 1, so that the control will be by definition 0 coding and 1 will be the reference coding. So that gives a more natural relation to what we want to measure, namely the loading of the grain with coding. So we have the linear 0 to 1 type of transformation. I calculate based on both images, calculate, and now I get a very high eigenvalue here. I can now apply it to my control image, and you will see that they are all dark blue, and I can also apply it to my image here, and you see that they will be of value around +1. In this case corresponding to green. I can choose the color bar to show you that dark blue is now 0 and 1 is the greenish color. And if you look closer, you can see that exposed areas of the seeds are dark blue indeed, and we now have a transformation which can quantify the loading of the grain or the rice in every single pixel. So I will call it rice coding index, or what I would prefer to have it. Let's say here we save that, and now we are ready to build a recipe. So we go in Session Manager to build a session recipe, and under processing again we choose the default general statistics, and we go in and edit the settings. In these settings we need first of all to find out where we want to measure the color or statistics, and we choose our segmentation from before, and in the selected foreground we want to actually apply a transformation now, which is our coded index, coding index. So that will give me my transformation measured on the rise and only on the rise. And then I can calculate the different statistics. I choose the mean, which will give me a measurement of how much loading is in average on the seed. And the standard deviation could be measured, but in this case we have fixed 0 because we now scale between 0 and 1. So, and the coding variation will of course increase the more coding you have on the seed. So it's natural to choose the coefficient of variation instead of the standard deviation. So in this case, we will choose the mean and the coefficient of variation as the statistics. The coefficient of variation will then code for the homogeneity or heterogeneity actually of the coding. So with these numbers, we will now have defined the coding recipe. I can still choose to put out PNG images. I can choose more, but I will just leave it here and put in a name. So rice coding loading and heterogeneity. Maybe I put a hyphen here. So I will run the session and save it before continuing. Yes, we'll call it that. Save it. And when I run it now, I will choose file load, browse, downloads, seed color measurements, seed coding measurements. I will select that folder. Has 6 images, and it works nicely. I'll say OK. I'm now ready to run. You see here we have 2 parameters only now. We have we have 3 actually. The total product area that we are measuring on, in case that would be interesting, but that's a good reference. The mean of the transformation, so that would be the mean loading. Coefficient of variation, so that would be the heterogeneity of the loading. So let me start running on these images and see what we get. So here we have the low amount of polymer, a little more again, and a little more, 40 milliliters. And here we have 50 milliliters, which was our reference. And here we have the control. So they have been measured, all of these, and you can see the measurements. So we should have an increase in loading here, as we see from 0.55, 0.69, 0.81, 86, 95, and around 0 for the uncoded one, the control one. We could also look at the coefficient of variation, which is quite large for the uncoded one, but this is not relevant. This is because the mean is so low that the variation will look high. But for the coded parts, it will be meaningful, and it will say that we have an increase in heterogeneity with lower amounts of coding liquid, except for the 40 milliliter image. So we could probably look into why that would be. I think the mean is quite okay. So there will be a further investigation on how this can be done, but let's just have a look at that image. let's have a look. The 40 milliliters. We can take that, and yeah, we can actually see that it does have a lot of heterogeneity. So also compared to the reference. So maybe we are just looking at a yeah, maybe an artifact from the sample preparation, but or an effect from the raw material, but indeed the heterogeneity is quite high also compared to the reference. And maybe also if we look at the 30 milliliters, which so it's difficult to say, but I think probably it's true that there will be a lot of exposed areas on this one here, and definitely much lower homogeneity than on the reference coating over here. So the next example is scorched particles in milk powder, and actually we are not going to build the session recipe for now, but just illustrate the application and then leave it up to you to be able to try to build your own recipe based on this. The recipe should be based on the MSI blob counter preferably, and that's something that you can try once you have downloaded the images put on our portal. The images look like this. So here we have a sample which is bad with quite a lot of scorched particles, as you can see detected on the right side of the slide. That can be done on any number of samples. Here we see another sample with less scorched particles, but still quite a few. So high quality milk powder will not have any or only very few scorched particles, and this is something that we should be able to evaluate with this recipe. The next example will be on the use of the MSI blob classifier plugin, and also a little bit about using the blob tool in connection with constructing session with the blob classifier. So here we have a sample of pellets with slightly different colors placed on a blue background plate. So the pellets and the background plate is quite similar in color, at least for the human eye, but we will see if we can create enough contrast. Otherwise, a differently colored background could be used, like a red or a green or a white or black background. But let's see what we get. I mean, we need to separate or segment out the pellets, and then we want to, let's say, measure the area distribution of the pellets and maybe some other distributions as well. So let's first of all define what is a pellet, and I will here try to take one of the light ones, one with some dots on, a dark blue one, and yeah, we can probably choose some more, and then we choose some background pixels in green here and here, and maybe over here. So we have foreground and background, and now we can do the transformation builder in CDA in order to separate what I painted red from what I painted green. And if I calculate here, I will get a signal to noise ratio which is quite large. So we have separated pellets from background with more than 200 standard deviations. So that's quite a good separation. And if I apply the spectral signature for the pellets, it looks convincing. So we go ahead with this and save the transformation. We call it blue pellets versus blue background. And then that is saved and can now be used in a segmentation if we want to segment out the pellets. So in order to make a segmentation, I choose MSI Segmentation Builder, and we use, first of all, our foreground background transformation here in order to get a good contrast to the blue pellets versus the blue background. We threshold at 0 and our foreground is greater than 0. So that is how it is in the standard setting of the NCDA. So we can try that out by pressing apply or apply as a layer. So we apply it as a red layer here. And now we see that the pellets have been found quite convincingly, and still they may touch each other because we have not done any separation of touching pellets, but we can definitely do so by taking on separate touching object using the default parameters, which is adaptive settings. So I apply it as a layer again, and once that has been done, then we go back in and we see now that all the pellets have been separated nicely. So let's save this, call it blue pellets versus blue background segmentation. I save it, and then we are okay on that. Excuse me. We try now to go to the blob tool, and I extract the blobs from our color image with a segmentation I just made. So let's select that and apply. Then we have all the pellets in our blob collection, which is a database of pellets now, and we have all the pellets here. We can click on one pellet and see different default parameters, and we can click around. We can also see actually where this pellet is in the original image. We can sort all the pellets by area. See the small ones on top and the larger ones on the bottom. We can remove the small piece of dust here, and then we are ready to go further. We want to create a feature set, which is not our default feature set. We could take and remove features. We would just want the area and the width, for instance, or maybe just the ratio with length and how circular the pellet is. So I can remove that feature. Just press delete here. So I have 3 features that I'm interested in about these pellets. I choose Save Feature Set, and then I save it as Pellet Color Features. And now I'm ready to close the blob tool and go on to build a session recipe that automatically measures pellet statistics. And we choose granular products, we choose blob classifier, and here we have a possibility to, first of all, put in our segmentation. So how do we define the blobs? That is with the blue pellets versus background. Segmentation. And what do we call our blobs? We call them pellets. So we get the right titles in the Excel sheets that we create with the recipe. And we can select which features to compute by selecting the pellet color feature set. Further, we can decide whether we want to just get the feature means and the standard deviations, or we want the median as well. But we take the mean and standard deviation, and we leave the rest of the parameters. I can click next, run session. We save it before we run, and we call it pellet statistics, true. And now we are running the recipe, and we can just run it on stored images in this case. Browse the, so we have some pellets here. And I think there are 2 pellet images in this. And we can just execute the session on all these images, all these 2 images, by clicking play. And here you see the first one and the second one. So we have all the features from the pellets here, average of the size and shape parameters, standard deviation, and here we go. We can see that the white dot pellets are slightly larger than the colored pellets. Same approximately the same ratio of width length, and so on. So we are ready to go, and we leave the recipe. We can now scrutinize the results in the Excel sheet, and we can also go back and check out the other output that came. Let's see here, preferences, folders, user folder, session, results, and we have a one called pellet statistics. We have run it one time, and this is our results. So I have the pellet statistics here. This is the Excel file with the 2 rows and the summary statistics for the pellets. So this was the final example of Session Manager, session building, and we hope that this gives you the ability to construct session recipe files and run them on a number of images and see how easy it is to do different types of routine tasks with very little user interaction. So good luck with your examples here, and look forward to hear your questions.
All right, everybody. So now we are ready to a Q&A session. I hope you noted down a few questions along the way. So please go ahead, raise your hand if you have anything. Have you all tried to make sessions already? Or anybody who hasn't tried?
Hi, Mikael. I'm just breaking the ice. So
Yeah.
You asked to raise the hand, so Aaron and I did, but then you didn't.
I didn't notice. Maybe
that
Sorry
was
about that.
We took it maybe too literal. I have. We have done some sessions and session builders, or builded some sessions, so to say. My question is a bit more simple than the types of analysis and statistics that you have done, as it's a thing that I do commonly. We obtain the pictures, and then I do like to view them under the different wavelengths. You know, in a specific setting, may it be the jet or whatever other sort of option you have as a view. Is that something I can also automate for then a series of images that I have taken, or do I have to click myself through and maybe export then those individual viewed images one by one? Do you understand my question?
Yeah, so you basically want like PNGs of the individual bands.
Yes, correct. And can I do that as a session?
Yeah, maybe you can do that as a session. Let me see.
Or somehow automate it.
Let me just share the screen again. And so we are changing this a little bit at this moment, but let me just show you how it can be done. I'll share the screen here. You probably can see in a minute, my Bidimeter lab.
Yeah, we see your screen.
Yes, and if I go to, you have the button here where you can export.
Yeah.
No, not anymore.
Okay.
Okay, so let's see. You have some scripts, so that's one option. You go into the script editor. There are some examples, and hopefully it will come up soon. Let's see.
You just mentioned that you're going to change. Does that mean that export function is going to be removed?
No, it means actually. No, it means that it will be more easy in the future. So that let me show you how it is today. Then I can explain what we are about to do. View examples. So you see batch scripts, convert, extract bands from all images in folder.
Yeah.
So, and if I load the example, you can actually see the C#, the small script doing this. And it's not very difficult for C programmers to sort of twist and tweak this, but it turned out that people didn't like to do it anyway. So we had very few customers daring to change in the C#, but you can use them as is. So that's something that is possible. But we realized that this is maybe a too nerdy type of functionality, but maybe still useful for some people. So that was one way, and the way we.
If you had an agent with the code base, maybe an AI can help us.
Yeah. I'm sure there could be a possibility to make the Copilot or ChatGPT change the program. So that could be a possibility. So the way we want to do it now, I may actually give you a small teaser on this. So there are two things we want to build, and one is that we have a much more flexible tool for constructing functionality, new functionality, and I will show you because it's only available in debug mode. So there is now a tool called Operator Builder coming up in future releases, where you can set up sequences of operations what you want to do, so you can probably extract bands and save them and so on. So there will be a lot of opportunity to even do some operations before you save and so on. So that will be a more flexible tool than programming in the near future. So we have a pre-release right now, as you can see, but it will be officially released in maybe June of this year, so in 1 month. The other thing is that we will, because what you are asking is a kind of conversion, not so much an operation. So we will go into these conversion things and also make them more easy to use to get in a, like a batch fashion. So here you can extract bands as a single image and so on, but now we want to do all operations that you have here under conversion. You should be able to do on all images in a folder, for instance. So conversion will be for things that are not directly image analysis. So you can say things like a different image format, but also if you want to have another color space, if you want to have, let's say you want to add a comment to all images. So you know that images have some description and so on that you can, let's see here, properties. Let's say you have some description that you want to add to all the images in your folder so that you can later on recognize that tag. Then you can put in tags in one or many images in the same function. So this will be on this menu. So that's the teaser for now, that we will change from scripting to more ready-to-use operations that will all be applicable to one file or a number of files. I hope that answers your question.
It sort of does, but so for now I would need to go via the script. The
I'm
script
sure Aaron
function.
can help you out.
And exactly, and then I will ask Aaron to take a look to do batch. I don't know if operations is the right word. You had another word.
Yes.
It's literally just a visualization, right? Not no analysis as such. Okay. But from June there might be other ways. On how to do that.
In the beginning, we will not have everything populated, but it will be more easy for us when you have a request. So we typically prioritize people who are on service contracts, of course. So if you have ideas, then let me just show you that as well.
You muted yourself, I think. Yeah.
Sorry, I muted myself. If we go to help menu, send us feedback and ideas. That, let's say you have an idea to a function that could be useful, then please send us. We also have the report and issue thing if you experience these things. So we try to make this more automated so that if you do report an issue, then we will also get the information we need from your computer. So it will give us the file logs and so on. So, but nothing about your data, but only issue logs.
Okay, thank you.
So that's another thing. So. Did that also answer your questions, Aaron?
I think his question
I have
was
a
totally
different
different.
Okay.
If you could, can I ask a question?
Yes, sure.
Okay. So it was regarding. I thought it was very interesting and useful, this idea of performing like a segmentation after a transformation, and then following that up with a transformation for the measurement.
Yes.
I think we might be able to use this. So you demonstrated 0 to 1, And there's another function in there, logistic.
Yes.
Could you just say a few words about that, if at any? I'd like to look into this, and so I was just curious about what other capability there was there.
Sure, I will. I may have a good example for you. Let me just see.
Because logistic, that's sort of like for classification, maybe, or something.
It's closer to classification.
Yeah.
So, but I think I do have a good example for this. Let's see here. I'm just looking through my big pile or backlog of slides. Let me see here. That was not the logistic one.
And perhaps in general, if you could give some examples of the types of, you demonstrate this measurement of the coding that was interesting, or of other applications for this measurement capability.
Yeah.
You could you could send me if you stumble
I
upon it.
will,
You could send it to me
will,
rather than taking other folks' time. Yeah.
Exactly. So thanks for that idea. So I will say just a general comment on logistic that you can choose in the advanced setting of NCDA. It will instead of like making the NCDA like linear, then it will saturate around -1 and +1. So it will not be directly a classification, but it will be more close. It will move into more or less reddish or bluish area and very little in between. So it will make it more obvious that the separation is clear. Let's say if you want, I have a good example actually from something close to some of your colleagues, namely the a salami, where you can see the fat part and the muscle part being separated more clearly in a logistic setting than in a linear setting. So that exists. And sorry, what was your other question?
Yeah. So the logistic is kind of like a different way of doing the -1 to 1.
Yes.
Yeah. So with respect to the coating example, where you were using the transformation as a way of essentially scaling the difference in color, right, between 0 and 1. Do you have so here this is an example of coding the wheats or whatever they were, the seeds there. Do you have examples of other things that your customers or other types of things that you can measure? I mean, you can measure anything, I guess, but
yeah, we can measure anything. So yeah, you can say any kind of process that changes the product. So you have coding is one thing where you apply a layer, but you can also have like a kind of an implicit coding. Let's say if you have things on the surface when you do malting of barley, during the malting process, you will create phenols on the surface of the barley, and you can use an NCDA to quantify the phenols on the surface. So they are sort of naturally developing in the surface during the germination process of the barley. So you can also do the same with other contaminants on the surface of the product. It could be molds, it could be other things coming onto. It could be, as one example here, we had the scorched particles in milk powder. It's also good because it's not like you see either a scorched particle or a milk powder particle. In powder, you see many particles buried beneath other particles. So you have all levels between an exposed scorched particle and a completely good powder particle, because if you have a scorch just below a layer of good product, then you can still see the scorch through the thin layer of milk powder because it's semi-transparent. And this is of course making the separation a little bit more complex, but it also makes it possible not only to measure the absolute surface of the powder, but maybe a layer of 0.5 millimeter or 1 millimeter thickness. So it gives you a much more representative view of scorched particles, that you can see things a little bit deeper down.
Got it. Okay, thank you.
Sure. Any other hands?
When are you expecting to release the thing that you're showing Jana? Perhaps I didn't hear you mention that.
No, but in June, I would say. We have it already in the current release, but only in debug mode. But it will be fully exposed in June.
Right.
Are these updates coming with like sort of a brief introduction as to what is being updated and what is different?
It always comes with a changelog. So if you go ahead and I can again just share the here we go to help. Help, user manual, software, changelog here. It's also on the website now where you download. If you go into Bidiomita website and you click on, you log in, you click on downloads, then you can see the changelog before you download. So that's a new functionality on the website. But when you go in here, you can see everything that changed in the current release and previous. So you see all the changes happening between releases. So you can actually search this text file if you want to, let's say, find something like blob analyzer. Then you can see what has changed in the blob analyzer, and yeah, check the next and go ahead on that. So it's just a way to maneuver and find out when it's time to update the software. I know we have spent the time now, but I have a very exciting thing I want to show those of you who are interested, and the rest of you are of course welcome to jump off. But I will show you one image from the new Bidiomita lab, a new option to the Bidiomita lab. So a camera which does complete VSphere, so visual and shortwave infrared. And I can just show you here the, so these are different materials. The top row is metal, so it's beverage containers, so pieces of metal cans, aluminum painted with different colors. And these are liquid packaging boards, so these are like juice and dairy containers. And the last row, the third row here, is plastic bottles or pieces of plastic bottle. The interesting thing about this image is that they all have different colors, so they come in similar colors, but only the material behind is the material behind is the same across each row, but different between rows. And I would just show you here if I can, because I find it quite exciting to see if I have. I would probably best do my transformation building. So let me just show you here on that here, all samples PPT, and I want to separate maybe the first two layers. So 1 and 2, let me calculate here and apply. So you see here how it can separate metal from liquid packaging board with almost absolute certainty across colors. So sorry for bragging about this, but this is just because I'm excited. I just found this small example here. So hopefully that could be of interest to some of you who wants to do more into material. It is a more expensive technology because the camera alone is maybe 10 times the price of a normal silicon camera. The instrument will not be 10 times the price, but it will be more than a standard Videometer lab. But again, if you need this kind of material identification, then I think this is a very, very interesting technology. So thanks for now. I see no more hands. So I hope you enjoyed the session, seminar here or webinar, and that you're ready to make sessions. And I will be happy to receive suggestions and questions by mail. And I will help you as much as I can to move forward in this exciting field. Thanks for now.
Thanks, Mikael.
Bye-bye.
Bye now.